Hello, I'm Constantin from Enviso, and the purpose of today's tutorial is to demonstrate how to conduct a measurement system analysis using Minitab. The method will be used to assess the quality check of smoked salmon fillet portions. So we are going to look at the measurement system analysis for binary responses. In other words, operators could make both good and bad decisions. This is called attribute agreement in Minitab. A binary decision is always made in an attribute judgment, meaning good or bad, white or black, pass or fail. This type of analysis requires only few steps. Set the standard, then we set the test, then we run the test, we analyze the data, and we build the action plan. Step 1. Set the standard. A true standard must be established that can be used as a reference for future analysis. Take at least 10 portions of salmon. Grade them according to your current technical specifications. You require portions that you deem to be undesirable and portions that you consider to be desirable. The ideal situation would be for 10% of your samples to be truly awful, 10 to 20% to be flawless in terms of quality, and the remainder to be in the so-called region of doubt, meaning not perfect, but not so bad that they cannot be accepted. Record your decision and be sure to maintain full traceability of these standard portions. Okay, now we set the test. Please open a Minitab file and go to Assistant, then Measurement System Analysis. And now we have Measurement and Appraisal. We choose Appraisal, Setup Study. So please click on Attribute Agreement Worksheet. Now you have a window that appears. You have here on the left side, upper left corner, number of appraisers. This is the number of people that you would like to test. Let's consider that we have 5. You could keep the numbers, appraiser 1, 2, 3, 4, 5, or you could even type the names. Maria, Ion, Marius, Anna, and Sylvia. So we have 5 appraisers. Number of trials now. That means how many times the same appraiser will receive the same portion. I would recommend 3 times. Now we have number of test items. That means how many portions do you have? Remember from the standard setup standard phase, we consider to have 10 items. So as we have at this moment the standard, we know that the item number 1 is, by example, good, item number 2 is bad, 3 is good, 4 is bad, good, 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 bad, bad, and bad. I'm just assuming that this is your standard. What are the values of your known standards? Good or acceptable item, we keep good. Bad or unacceptable item, we keep bad. And you click OK. Now you have the test setup. You have here the run order, you have the appraisers, Maria, Ion, and so on. You have the trials, you have the test items, results, and standards. Now we have to run the test. As you see here, we have these columns: appraisers, trials, test items, results, and standards. So we are going to give to Maria item number 9. If she decides that this item is good, then she's wrong. if she decides that this item number 9 is bad, then she made a good appraisal. And we continue for all of them, as you can see here, till the end of the spreadsheet. Good. Now let's see how we analyze the test. I've sent you a file, MSA attribute Vega Salmon. There is a fictitious test inside, just in order to show you how we can analyze the results. So we go to Assistant, Measurement System Analysis, and we click on Analyze Data here on the right side, Attribute Agreement Analysis. We click on it. We have all the columns, as you can see, in corresponding fields. And in the last field, we have to mention good. Value of good or acceptable items should be good. And we click OK. Now we have the overall performance of the team, 78%, which is not very good, I would say. We have overall error rate, 21%, good rated bad, 22%, bad rated good, 20%. Mixed ratings, same item rated both ways, we have 28%. Now, we can see here my fictitious team, Maria, Marius, Ioan, Gheorghe, and Anna. We have the team average, and we can see that Maria is below this average, only 66% accuracy for her. These comments here are very important. Low accuracy rates means, for some appraisers, may indicate a need for additional training for those appraisers. If you obtain low rates for all appraisers, that may indicate you need a more systematic training, or you need to review the operating definitions. You need you need to fix incorrect standards. If you have high misclassification rates, that may indicate that either too many good items are being rejected or too many bad items are being passed on. High percentage of mixed ratings may indicate items in the study were borderline between good and bad, thus very difficult to assess. And now we have attribute agreement analysis for each of them, variation of their performance. And you see here what you can expect for them, for each of them, with an accuracy of 95%, a trust of 95%. So what we expect from Maria, you expect from her a 66% accuracy. Of course, she could have good days with 82% accuracy, but also she could have bad days, 47% accuracy. So again, you have the rank here, and then you have percentage of appraisers and standard. How many times Maria detected good parts, and how many times Maria detected bad parts. So the probability that Maria detects good parts as being good is in average only 53%. The probability that Maria in average detects bad parts is 80%. So she could detect what is wrong, but she cannot detect what is good. And she has this temptation to rate as bad something which is still good. What graphs do we have here? Percentage by standard, good and bad. So good were rated only 77% as being really good. Bad, 80% of measurements were rated correctly. And we also have percentage by trial. Percentage by trial meaning for the first, second, and third round of trials, how the appraisers acted as a team. And we have here, during the first trial, they had an accuracy of 72%, the estimate. During the second trial, it was a little bit better, as a team, 82%. During the third trial, 82%. There is another interesting graph here. Most frequently classified items. So we have here item number 9. It was good, but it was rated bad in 33% of measurements. That means item 9 is really borderline. And maybe you should use these types of portions to train the people. Those portions that created the problems. And we have bad rated good, item number 1. All of them said that item number 1 is good, as you can see, 100%, but in fact, he was bad. Maybe it was a defect, and they weren't trained to detect that type of defect, so they just let it go. This graph is very important for the training that follows the assessment. You can see what item created the most of the problems, and you can insist on that item. You can analyze with them that item in order to see what was the source of error for them. And then, of course, we have a percentage of good rated bad by appraiser. Misclassifications, sometimes they rate bad, sometimes good, and percentage of rated both ways. So again, Maria, unfortunately, she's the weakest appraiser, but we also have Marius and Anna that maybe they should be trained more because they have 80% accuracy. So I would be more than happy to analyze a real test. So please run your test and let's analyze the results together.